My name is Ryan Kenney, and today we're going to talk about all the changes that one makes when switching to Docker. This is going to be stuff like process, stuff like tools, going to be a comprehensive overview of the entire pipeline and things that have to change. So there's going to be a lot of material, try to get through it as fast as we can, and then also leave some time for questions and discussion at the end. Sound good? All right. So I'm assuming that most of you are sold on containers, otherwise you probably wouldn't be here. However, it's important to get a common understanding of what containerization is and why we're moving to it, other than that it's just the next cool thing. So with that, a good place to start is, well, what is containerization? Our friends at Docker have this to say. A container is a standard unit of software that packages up code and all of its dependencies so that the application runs quickly and reliably from one computing environment to another. In layman's terms, this basically says we're bundling our application binary plus the runtime it needs in order to execute in such a way that it works the same way no matter what machine I'm running it on. This is not too dissimilar from Java's write once, run anywhere paradigm. So this is kind of helpful. It doesn't really tell us a lot about what's going on. So what I found is that a good way to understand any one thing is to compare it to something else we already know. So containerization compared with virtualization looks a little bit like this. With virtualization, we were abstracting away the infrastructure. So I could have multiple virtual machines, and they all thought that they had independent hardware by way of the hypervisor. With containerization, on the other hand, what we're doing is we're abstracting away the operating system via the container engine, that is Docker. So what does this mean? Are containers the way of the future and virtual machines are on the way out? No, not at all. Virtual machines play a very important part. If you're hosting your own cloud or maybe you're using AWS or something, whether you like it or not, you are using virtual machines. So what containers really do is they allow us to package up our application at a smaller level. We're just bundling up the libraries and the application, and that allows us to be a little bit more flexible, a little bit more agile, if I may. So what does that do for us? Okay, we're abstracting at a different level. How does that help you, the developer? So containers are created and destroyed really quickly. By really quickly, I mean less than 50 milliseconds. And you compare that with a VM, and the difference is pretty profound. This is helpful when you're talking about things like making rapid changes, spinning up environments, spinning environments up and down. You're still bound by the startup time of your actual application, but that's it. You're no longer bound by, say, the requirements to bring up your infrastructure. So VMs helped us conserve machine resources, right? You could use a lot of hardware, and that's how Amazon has helped be so successful. What Amazon did was they took all of their hardware, and they were able to make virtual machines that made better use of it. We're able to do the same thing, but with containers. So at a smaller level, we're able to take a single VM and run all kinds of different things on it, isolated from one another. Environments are very easy to reproduce. So in Docker, what we have is this thing called an image. It's no different than a VM image, like a VDI or an AMI. So what you do with a Docker image is you can create containers, on the fly, either in, multiple in one environment or, the same one across multiple environments. And that allows us to easily reproduce an environment. And again, combine that with it being very quick, you can start to see how this plays out. So, as the title of this presentation suggests, changing the underlying build artifact is probably going to have a pretty rippling effect on our entire pipeline. And this is true of any paradigm shift. So when virtualization first became popular, we heard terms like disposable environments, disposable computing, those sort of came into vogue. And when we started using cloud providers, it changed the way that we thought about the cost of system resources and vertical scaling. Vertical scaling being when you increase the resources of a single machine. So too with containerization, are we rethinking the way that we design and deliver software? So using easily deployable containers will require us to re-examine a lot of stuff. So our static analysis tools, both for detecting security vulnerabilities as well as general code hygiene. We're going to want to rethink our approach to testing, both manual and automated. We're going to want to look at the tools we use to build out our Docker runtime environments. So starting from the lowest level, let's start taking a look. And the lowest level here is the application itself. So that is the thing you're writing code for, the thing running in the container. So the application's main interaction with its runtime, formerly a VM and now a container, comes in the form of configuration and pre-required software. We're going to take a little look at both. So here on the screen, I have your standard Java enterprise application. So we've got a virtual machine. We've probably got HTTPD running on it, Nginx, something like that. We've got Tomcat installed. And then our application might be composed of multiple web applications, multiple wars or web archive files. Now, we stuff those into Tomcat, and there we go. We have an application. So the thing that we're probably tempted to do in this case is just stuff it all into a Docker container, call it a day. That can work. I mean, nothing will stop you from doing this. However, it's not, it doesn't follow a lot of Docker best practices. For one, we have what's known as the single process rule, which says that a Docker container should do one thing and it should do it really well. And this should sound, for those familiar with microservices, this should sound very familiar. Now, with the single process rule, we might think, okay, these, we wanted to share the Apache Tomcat environment, and that's why we stuffed all these things together, but we don't need to do that anymore. Remember, Docker combines an application and its runtime environment in a way that makes it easy to share this common code and common configuration. So what should we do? We break it apart. So instead what we have are individual Docker containers for our applications. And with Docker, we can use a shared Tomcat base image that prevents us from having a lot of repeating, that prevents us from having to basically duplicate Tomcat 4 times. Now, this is great. This is actually a good start. However, we can still do better than this. A lot of frameworks such as Spring Boot, such as Lightbend's Play, have embraced this idea of an embedded web application manager, Tomcat being the web application manager. So again, whether you're using that or Netty or Jetty or something like that, what these frameworks are doing is allowing you to embed the necessary J2E libraries that make this stuff work. You can basically pull Tomcat out of the equation and simply stuff those necessary libraries into your application. So you have a single executable jar. So one of my customers went from a 380 megabyte Docker image down to, I believe it was 170, something like that. And that was just by switching to embedded. So again, it's a pretty easy change to make, and it follows, it follows the Docker paradigm a lot better. So instead of having a hefty Tomcat base image, we just have a JRE, and we have a single executable jar. So now we want to look at configuration, right? So how does your application typically interact with its environment? There are a couple different ways. Generally, they tend to be through property files, XML files on the file system, or perhaps environment variables within the system. So in Docker, both of these things are very simple to do. We'll start with the environment variables. So when you issue a command to Docker and say, Docker run my fancy image, you can simply pass in key value pairs that say, what environment variable name you want, and then the value. This is important because the environment variables that you might have had in your virtual machine, the ones that are on the host running Docker, do not automatically get sent into Docker. That said, for files, you can map a single file or an entire directory on the host into the Docker container itself. And you can share these volumes, they're called volumes, between running Docker containers. So this allows you to share common configuration or have persistent storage. This basically makes your Docker containers have a file system that gets injected on the fly at runtime. And again, this is not super dissimilar from just standard mounting volumes in Linux. So if you understand that conceptually, this isn't going to be that foreign of a concept to you. So again, we also want to look at security. So I would say the biggest change in the security posture of your application when moving to Docker is that unlike with virtual machines where you had multiple processes running in one spot, you're not going to have that in Docker. Remember, we want just your Docker container should be a single executable. So how are we going to do our security scanning? We're probably going to need different tools, right? So I've listed a few over here on the side, Twistlock, Aquasec, Sysdig. They're all Docker-aware applications. That means they can scan the host running Docker, and they can also scan your running containers. And it's very important that your security tools be aware of Docker, because if you're running an application, or rather a container as root, let's say, if that gets compromised, or say a vulnerability in the Docker engine is compromised, there goes your entire system. That means all the containers running on it. So Docker makes itself a very, very high-value target in these circumstances. So you absolutely need to start thinking security and start thinking it early. With regard to the containers themselves, tools like Twistlock can monitor your running containers. You can set policies that say if these containers are doing X or they're misbehaving, you can set them into quarantine or you can kill them altogether. Now, we don't want to wait until we have a running container to start worrying about security. One of the nice things with Twistlock, really all these tools, but I've been really impressed with Twistlock, is there's a CLI that you can use that basically will scan your image at CI time. It takes like 8 to 10 seconds. And what that's going to do is that's going to tell you whether what vulnerable libraries you have within your image. It's going to catch things like if you are running the container as root, so if you don't specify another application or another user account to run as, it's going to flag that. And you can set it up so that will fail your build, or you can set it as a warning, whatever your organization prefers. And that said, these tools are different. They all perform very similar tasks, but you're going to want to do your research to figure out which one works for your organization. For example, Twistlock is kind of an all-in-one deal. So you get the monitoring, you get the dashboarding, you get the runtime and build time security scanning, but that's it. You get it all together or you get nothing. Sysdig is a little bit more component-based, and that is reflected in the pricing model. The pricing model for Twistlock has recently come under scrutiny, at least from some of my customers that are using it. So it's definitely something you want to take a look at. I never have to worry about the money. I just implement stuff. But there are definitely people that do care, so you're going to want to take that into account when you're picking what tools you want. All right, so we've got containers, and that's great, but there's still a fair amount of work that we need to do in order to get the most out of them. And that's where container orchestration comes in. Now, we don't really understand why we need container orchestration at the moment. We've just talked about running a container, and that's pretty easy. You just say Docker run, maybe pass in some flags, and that's it. We call it a day. But when we're done with the hello world example, we start to look at the real world. And the real world often is very complicated. So in the real world, we don't just have one application we want to run. We might have an application suite, so we've got to run different we've got to have application 1, application 2, application whatever. And then we also want to be able to scale those. We don't want to run just one, so we have to be able to horizontally scale, make more copies of the same application. But if we do that, then we also have to load balance. And we're also going to want to share configuration between those things. We don't want to have to keep repeating ourselves. So we also need to be able to share volumes, which we talked about before. We want to be able to network these things so that some can talk to others. And I don't want to be bound by a single virtual machine. If I have to have one virtual machine running Docker, then I haven't really gained anything with containers. Because if that machine crashes, then all of my applications go down. So things, aren't as simple as maybe people like to make it seem in those, online tutorials that you go through. But that said, Docker has a way to handle all this stuff, and people are doing this, right? So it would be nice if there were a tool, designed for running Docker containers in a production-like environment, made by people that actually knew what they were doing and had been doing this for some time. Our friends at Google have done this, and they have created Kubernetes, what is perhaps the most popular container orchestration tool on the market today. So we're not going to go over everything there is to know about Kubernetes. That would be an entire talk in itself. But we will go over some of the key features that sort of address the concerns we just talked about. So service discovery and load balancing, again, if we want to be able to horizontally scale, I don't want to have to set up a load balancer myself. I want Kubernetes to do it for me. You have internal DNS that makes it very easy to do this. As you scale your containers and add new ones to your application, those automatically get discovered and integrated into Kubernetes. Storage orchestration. I mean, really, we just want to be able to create volumes and share them. But what Kubernetes will also do is it has different storage drivers. So if you're using Amazon, for instance, as your cloud provider, you can have a direct interface with EBS or with EFS and tools like that to manage more sophisticated volumes. Automated rollouts and rollbacks. So with Kubernetes, you describe exactly what you want deployed. So what your containers are, how you want them configured. And when you make a change to that, say, I'm updating my application to be a new version. When you change what it is you want deployed, Kubernetes will keep the old thing up, stand up the new one right beside it, wait till it's responsive and actually working, and then start transitioning traffic over to the new services. You also have the ability to do rollbacks if you want. If things start failing, Kubernetes will automatically do it, but you can do it on command as well. Resource utilization. So we talked about how Docker and containers make resource utilization a lot more efficient, but with Kubernetes, we're doing it at scale. So we're now talking about a cluster of hosts running Docker. And basically all you have to do is when you say, hey, Kubernetes, create these containers for me, you tell it how much RAM and how much memory it should be, or excuse me, how much CPU and how much memory it should be using, and then it will decide which host should be running those containers. And should the situation change, should there be a more efficient place to be running the containers, Kubernetes will automatically move them. So you know you're going to get the best use out of your resources with Kubernetes. It's self-healing. So I didn't mention this before, but if your Docker container crashes, that's it. You got to make a new one. So that would mean constantly monitoring your containers and recreating them if need be. With Kubernetes, that's not the case. Any container that crashes will automatically be brought back. Configuration management, either secret or not, with Kubernetes, you can create things called config maps that store values that you can inject either as files or as environment variables. So it's very easy to share configuration between your applications. And then finally, again, this sounds like a complicated system, and as we're going to see on the next slide, it kind of is, but it's still relatively easy to install. So if you use a tool like Kops, I don't know how many of you have heard of Kops, but it allows you to install Kubernetes onto, specifically into AWS. It's primarily geared towards that. Makes it easy to have horizontally scaling nodes. It's great. If you're working in your own private cloud, KubeSpray is actually really great because it requires you to actually provision the nodes beforehand. So you just give it a set of IPs, tell it which IP should be doing what, and KubeSpray just creates a cluster for you. So we're not going to get too much into this, but I do want to touch on the architecture of Kubernetes just so we kind of understand what it's doing and why this isn't a simple solution that you could roll yourself. So up here at the top of this diagram, we have what's known as the control plane or the Kubernetes master nodes. What they do, they basically maintain the metadata of the cluster. So we've got an etcd database. That's where all this ephemeral storage is stored. We've got a scheduler that tells which node should be doing what. And finally, we have an API server that actually is accepting user commands or maybe commands from your CI tool, whatever. And it's actually acting on those. So then the API server talks to the worker nodes. So these worker nodes, their sole purpose in life is just to run Docker. Again, it's what we were talking about before. These are going to be VMs running Docker and running whatever containers the API server tells it. We have kubelet here, which actually manages the Docker containers themselves and makes sure they match your specifications. And then we have this kube proxy component that handles the networking. So there are all of these different pieces interacting and working together to actually deliver this solution. So we've talked enough about Kubernetes, at least for now. So want to talk about some competitors. Red Hat's OpenShift, maybe one of the more well-known ones, is actually built on Kubernetes. So it's essentially, they took Kubernetes, they configured it, they added some additional functionality, and they gave it their Red Hat brand support. So there's free and paid versions. The free community version tends to lag behind a little bit in terms of functionality. So anytime they add a new feature, it goes to the enterprise version first. But most times that I see people pick the enterprise version, it's because they want the Red Hat support. I haven't seen too many people upset with the slower release of new features. Like I mentioned, Red Hat's OpenShift is built on Kubernetes. So that means we have all of Kubernetes plus some additional features. I've only listed a couple, there's plenty more, but these are my favorite ones. So most importantly are the built-in CI capabilities of OpenShift. So without installing a CI server like Jenkins, you can use these things called build configs and image streams, and these allow you to, from the version control system of your choice, pull in Docker images, or rather pull in Docker files, build Docker images, and deploy them. It's a little rudimentary to use for your primary application, in my opinion, but one thing that I've used it for is bootstrapping my CI tools. So I can create an OpenShift cluster via an Ansible playbook, and then without ever pressing another button, I've got a fully configured Jenkins, SonarQube, and Nexus all talking to each other. So that's pretty cool. The DNS routing in OpenShift, one predates Kubernetes external DNS routing, and it tends to be a bit more mature. Now that gap is closing. Kubernetes calls them ingresses. OpenShift calls them routes. They perform basically the same function. It allows you to access your applications externally via DNS. I've had a lot of success with OpenShift's routes. And then we'll talk about this a little bit more, but there's built-in templating. So the way that you create objects in Kubernetes or OpenShift are with these humongous YAML files that contain definitions of all the things you want to create. There isn't a way to template those natively in Kubernetes. There is in OpenShift. It's a pretty nice feature. By default, OpenShift has a lot more strict security defaults. You're not going to be able to view it now, but once the slides are available, you can go click that link, or just Google OpenShift versus Kubernetes specifically for security. And again, this fits the theme. There's less to do yourself. Red Hat has implemented a lot of stuff for you, but it's much more opinionated. So if you want to change something that OpenShift is specifically doing, it's going to be an uphill battle. So if you want more control, you're probably going to be better off with Kubernetes. If you want something that's a lot more convenient out of the box, OpenShift is probably the way to go. All right, so this is more of a series of solutions. So there are hosted solutions. So what is that? Essentially, your control plane, that is the Kubernetes master nodes, are managed by your cloud provider. So this diagram here at the top is EKS, known as Elastic Kubernetes Service. That is Amazon's hosted Kubernetes. So this is cool because it reduces the number of components that you have to manage. So that means you're no longer worried about, one, creating your control plane, but two, you don't have to worry about making it highly available across multiple availability zones. Amazon does that for you. Now, of course, Amazon does that for you, but also at a price. So it tends to be more expensive than if you were to just host it yourself, which of course makes sense because otherwise it wouldn't be advantageous for Amazon to be hosting it for you. That said, if you were planning on building a very, very large control plane, then you may actually end up saving money, but that tends to not be the case for most people that end up using EKS. There is a longer wait for new features. It's an added layer of indirection. So Kubernetes releases a new version. Amazon has to make sure it works with their solution and then roll it out to their customers. So there's never going to be a way of getting around that. It's just, if you don't mind waiting for the next release of Kubernetes, then a hosted solution might be good for you. So I've also listed a couple other hosted solutions. Google's GKE, or Google Kubernetes Engine. Again, Google made Kubernetes, and so if you're using Google Cloud, you're getting it straight from the source, so that might be a good option for you. ECS is Amazon's Elastic Container Service. This is dwindling in popularity. So ECS is a non-Kubernetes-based container orchestration tool. I didn't want to spend a lot of time talking about it. Again, it is becoming less and less popular now that Kubernetes has kind of taken off and that there are hosted versions of it. All right, so we have containers and we have a platform to run them in, but how do we describe what should run and where? And how does this fit into a typical deployment process? So a very, very simplified version of a deployment process looks a little something like this. Your code comes from GitHub. It goes into your CI server like Jenkins. You build and then publish the artifact and put it into Nexus. And then finally, you have some sort of deployment orchestration tool that takes that artifact and configures it and puts it in your deployment environment. Maybe you have chef recipes or Puppet scripts or Ansible playbooks, something like that. So the main things that we've changed here are the deployment environment. We've changed the build artifact. So, how does this affect the way that we're going to start installing our applications? I mentioned these before, but essentially what we have in Kubernetes land are what are called API objects. So these are things that describe what it is you want deployed in a very verbose fashion. So what I've taken here is a simple deployment API object, and we're just going to look at the containers section because, again, this is the most intuitive piece of it. Everything under containers refers to a Docker container that we want to run. There's a lot of other stuff we could add here, but this is the most simplified version. So this doesn't look too complicated, right? We've got a name, so presumably that's what the name our Docker container is going to have. We have an image. The first part here is the URL for our Docker registry. Then we've got the name of our application. And then finally, we have a version that we want to deploy. So 1.2.6-18, for example. This env section describes all of the environment variables that we're passing into our application. So we have some that are just hard-coded here and a few that are coming from what's known as a Kubernetes secret. And this all looks great, but one thing we might notice is that I couldn't use this same definition for anywhere but one environment. So for example, I don't need to know what the variable config profile means or does, or how it impacts the application at all, but a value like dev seems like it only works in one environment. It's probably not a value I want in my production environment. More obviously, if we go back and take a look at the image that we're deploying, a very specific version like 1.2.6-18 might be the value we want in dev, but I probably want to have something differently deployed in test or in prod. So, a lot of this is probably going to be the same, but there are a few things that are environment specific. So how can I maximize reuse while still having definitions for various environments? And the answer, of course, is generally, as software engineers, we know that we want some sort of abstraction. We want some sort of ability to template things. So what are our requirements for a templating tool in this particular case? So we want to be able to define the environment-independent things only once. Again, that's going to be like 95% of the YAML file. But we also want to be able to take those environment-dependent values, group them together by environment, and then be able to apply them at some point later. So I pull down an object definition, I take the configuration for a specific environment, I combine them, and I go, right? Kubernetes makes it easy. Again, if I can get a YAML file that represents a particular environment, it's a one-liner. So all we need is a tool that can handle the other two parts. So in true Agile fashion, we have a very, very MVP solution down here at the lower half. So the most basic templating solution we could come up with is to basically store our key value pairs of environment-dependent values in a properties file. I apply those. I then use this very hideous sed command, this god-awful sed command, to then parse the YAML file, take those key value pairs and inject them into the YAML file, ultimately giving me an environment-specific YAML file, and then I use kubectl, which is the tool that you use to manipulate Kubernetes. I use that to apply the YAML file, and boom, we've got our templating. We have only the things that need to be defined once, and we've got our environment-dependent stuff bundled together. Now, this might work great, when you first get started, but obviously we want something a little bit more robust than ever having to use sed. So what do we have? There is basically the de facto templating tool on the market for Kubernetes is Helm. So it is a package manager. Sticking with the maritime theme, the templated Kubernetes definitions that we were talking about are called charts. You basically use the Helm CLI to do all of your deployments. So if you want to create, update, or roll back a release, you use the Helm CLI to do it. So this is another artifact that we have. So we have our images. Now we have something like Helm charts that control our configuration. Your charts can be stored in a bunch of different places. GitHub, Amazon S3, Harbor, if you've used that. These are all popular tools that people use. Technically, you can use any HTTP server that you want. All you have to do is give it an index.html file and throw in some metadata, but that's really not advised. It's better to go with one of the more well-known tools. So some things about Helm. It's a great tool. The versioning scheme that you have to use is Semver. Now, that's probably not going to be a problem for most of you. Most people have kind of adopted Semver as their versioning scheme for all of their artifacts. I don't like being told what to do, so it's kind of a downer for me, even though I do use Semver probably 4 out of 5 times for these types of things. The error messages aren't always helpful in Helm. Again, they've got a great tool, but they've got a long way to go. So just a word to the wise, if you're ever developing a Helm chart and you get an error that says release foo already exists, but foo is the release that you were trying to update, what it means is that you have a syntax error somewhere in your chart, which you wouldn't guess based off of that error, right? So they clearly have some work that they need to do. All right, now let's go back to our API object definition, and let's see what it looks like when we use Helm. So some of you may recognize this syntax, the double curly brace syntax. This is the Golang templating engine. That's basically what Helm uses. And so let's take a look at what it looks like. So we use .values, image tag, for example. This pulls in the values that we pass in at runtime that are environment specific. We do the same thing for the config profile. You'll also notice up here at the top of the environment block, we can say something like with.values.extra environment. And what this allows us to do is actually take, instead of just doing a plug and play version of properties where we just say, hey, take this, wherever I put this values.profile, put in this particular value. What we can actually do is generate more complex YAML structures. So here it's fairly trivial. All this really allows me to do is for different environments, I could have an entirely different set of environment variables. It might be useful, might not. What people tend to use this pattern for is making more abstract charts. So you can have a hierarchy of charts with Helm, and this allows you to create something more abstract so you can further reduce the need to duplicate things between your applications. So just something kind of snazzy you can do with Helm. Looking at the OpenShift template version, we don't really have any of the snazziness of Helm. Again, this is what's baked into OpenShift, but it's kind of just, like I said before, the plug and play thing. So I just say, hey, wherever I put this, my app version, replace it with whatever value I specify at runtime. Again, this is probably fine for most people. I've seen a lot of good CI/CD implementations that use either OpenShift templates or something just as similar. So this is, while it's not as cool as Helm, it certainly does get the job done. And while we talk about secret values, or putting in values in general, I want to talk a little bit about how you might store sensitive data. So there are tools. The only one I'm going to talk about today is called Vault. But Vault's sole job is essentially to store sensitive data. It stores this encrypted at rest. It is encrypted in transit. And you can interact with Vault in a couple of ways. So you can provision your environment, Kubernetes, OpenShift. You can provision your environment to pull values from Vault and store them in the secret object that we had talked about before, or you can actually pull them in at runtime. So when you launch your application, you can pull directly from Vault and have those values stored, say in a config file on the container running your application. So this tends to be the way that a lot of companies that are very security conscious tend to go, rather than just hard coding them into a Kubernetes secret manually. All right, so we've covered a good bit now. However, let's talk about testing. So while the way that we deploy our application doesn't really fundamentally change what the application does, there are still things that it does affect, like how you test and how often you can test. So let's talk a little bit about that. Primarily what I want to talk about are what are called ephemeral or dynamic environments. So with the ease of deployments, again, it's very easy to describe what we want to deploy, and it's very easy to describe how it gets deployed. Well, now we can actually create an environment in seconds, really. So I can leverage my deployment automation that we talked about before, our Helm charts, our Kubernetes objects. I can leverage all of that stuff to create a test environment on demand. So the benefits should seem relatively obvious, but we'll go through them, or at least a few of them. So we've got a better use of system resources. Again, I don't have to have a test environment for every tester, or I don't have to have a test environment for every possible use case up at the same time. This allows me to, start thinking about integrating with with my automated test, with my automated pipeline. I can have feature branches or pull requests actually spin up their own unique environment, deploy, their modified version of the application, and start running tests against it. So this is pretty big. I mean, it was possible before with strictly with virtualization, but again, we have the ability to create things a lot faster now. So we're able to move this a lot earlier in the process, and it's a lot cheaper to do. Another thing that's nice about this is it does test your deployment automation. So we're not ever doing anything against prod for the first time. So this includes, the code that is actually the YAML files we talked about before. This also includes the code that you write up in Jenkins that says, put this stuff in this particular environment. We're testing that stuff all the time now. So it's never going to be that we discover it, at 7 p.m. on a Friday. Another obvious advantage is that there's no more fighting over static environments. So the places I've worked that did not have the luxury of ephemeral environments, there would always be some sort of contention between teams, especially for larger organizations. There's always going to be contention between teams that want to use, say, the test environment to test some, high-speed new feature that they just implemented. But they don't want to have other teams testing things in that environment, especially if they're dependent, because then they won't know if an issue is their own or if it's from this other thing. So there would always be fighting over who got to use which environment, or they would just all use the same environment, and then they'd have a hard time figuring out, whose bug belonged to who. So with ephemeral environments, that problem basically goes away. So how do we use this in automated testing? I've got a very, very simple pipeline here on the left that can kind of illustrate some of the benefits that we get from it. So, for starters, we build our application, we build our Docker image, and then we can build our environment. So this is an interesting trick that allows us to, because this can be done asynchronously, this allows us to do things like unit tests, static analysis, whatever security scanning we want to do, whatever you've got in your CI pipeline before you're ready to run your functional and integration tests. I've had to use this approach in a few cases. So one of my clients had a quote-unquote microservice that took 8 minutes to start up. So that's no good from I want to be able to bring up my environment and tear it down mentality. However, from the perspective of CI, there's plenty of other stuff I can do in the meantime if I build the environment in earnest of eventually testing it. If I bring up the environment and Sonar happens to fail and say, yeah, this is no good, we're not going to continue, okay, I wasted some resources for like 3 minutes. The environment gets torn down, and it doesn't matter. So as you can see, you're able to run your tests, you're able to do that, but effectively at the same speed as if you had a static environment. Because by the time we start running these functional and integration tests, the environment's already up and running and ready to go. And the main benefit of a static environment was that. It was up and running and ready to go. You didn't have to wait. But if we can do the same thing but with ephemeral environments, that's a huge win. Another thing that you'll notice here is that I put my test in containers as well. So you don't have to do this, but there are a couple of benefits to doing it. One, you're leveraging your infrastructure a little bit more intelligently, so you're not struggling with your Jenkins agents trying to do a whole bunch of stuff at once. You can leverage the power of Kubernetes, which again has a bunch of different containers doing a bunch of different things. Another advantage to that is you can deploy your tests sort of in the same namespace, so in the same network as your applications, and this allows you to use maybe a private API or have direct access to a database so that you can set up more complicated scenarios instead of having to poke through the UI, taking a tremendous amount of time to set up your test scenario. That said, you're not going to want to do all of your tests like this. You're going to want to have black box testing, but if you want to be able to test really complicated scenarios really early, really quickly, then it's something you want to consider. Again, the more testing, you never want to limit yourself. The more testing you can add, the better. And speaking of more testing, we've only really covered a portion of it. So there is still manual testing. For example, what about usability testing? What about exploratory testing? These are avenues of the application that need to be tested, so we want to have a mechanism for doing that. So being able to create environments on demand, via Jenkins job or whatever your CI build server is, you create a job that enables you to create an environment and specify a specific version of your application. So you might do this to clone an existing environment. So say you want to do some destructive testing on effectively what is deployed in prod, but you obviously don't want to do that against prod or even your test environment. You don't want to destroy anything in there. So you can create a copy of it and basically do your testing there. The other example is, like I mentioned before actually, for a feature build. So I have a feature branch. I want to do some manual testing on it before I actually merge it into master. You can do that. You want to be able to support both of those options. This is a great place to start if your organization is lacking in automated tests. So automated testing is great, and you obviously want to move towards that. But if you don't have them yet, you shouldn't wait to have automated tests to start building ephemeral environments. And the reason is this. If you build this capability to bring up ephemeral environments, once you actually start developing your automated test, you've already done a lot of the hard part, right? You've already got the logic to bring up an environment, so it is, with relative ease, you can then incorporate your new set of automated tests whenever you develop them into your pipeline. One lesson that I've learned is that you want to set up time limits to prevent misuse of these environments. So again, if you don't have time limits, people might forget to tear down the environment, and then you're just wasting resources, which kind of defeats the purpose. You don't have to go crazy with checks and guards and input validation, but just, again, remember, anytime you build something, there are users, and users like to wreak havoc. Final point, so being able to create on-demand ephemeral environments allows some of the non-technical folks to be able to take a look at what you've been doing, what you, the developer, have been doing without having to bother you. So this means that your Scrum Master, your UI UX people, your managers, they can all go and create a running version of the application as you're developing it and start taking a look at this stuff without you ever having to merge it, and most importantly, without ever having to go and bug the developer and ask them to take time out of their day to help them see it. All right, so let's start wrapping up with just some wisdom that I've gained over the years, specifically with what not to do when you start your Docker journey. So analysis paralysis, over-architecting, whatever you want to call it, if you try to get a perfect solution the first time and try to make everything perfect before moving on to the next step, then you're going to have a bad time. So, I mean, this is Agile, right? So you want to get an MVP. You want something that works. You want something that delivers value, and you want something that you can hopefully build on later, but you don't want to get wrapped around the axle trying to make, one piece of it perfect without implementing the rest. It's better to have an MVP of the entire pipeline, of the entire change, than just part of it implemented really well. So the other thing you don't want to do is develop in isolation from the rest of the organization. So again, think of the rest of the organization as your stakeholders. We've talked about all the different aspects that are changing. So think about the organizations that exist in your own teams, right? Like you've got security teams, you've got probably a testing team, you've got multiple application teams. However your organization is divided, if you're going to change the way these people are working and operating, then you're going to want to make sure you involve everyone in the transformation. You don't want a siloed DevOps team silently working in the shadows, subverting everything and not really communicating. The next thing you don't want to do is Dockerize an application before it's ready. So what does that mean? So Dockerizing an application specifically means, putting your application binary into a Docker file. But what happens when your application is extremely stateless? When your application is extremely stateful? That's going to make it hard to scale. That certainly goes against what Docker is great at doing, which is scaling. If your application is very tied to a particular platform, it's not platform agnostic. A lot of applications aren't, just because that's how they were built. These are things you want to look at before you start, writing your first Docker file, and before you start, trying to change the world and switch to containers. Because what ends up happening is you get a very rough solution because your application just doesn't work well with Docker. And then you end up thinking, well, Docker just sucks, but my application doesn't run very well in it. So it's important to do a little bit of analysis up front before going straight in. Another thing you don't want to do is leave security till the end. I know I don't have to tell this crowd this, but I see it over and over, so I'm going to say it anyway. You want to shift security as far left as possible. We've said that a couple times now. You want to be thinking about those security tools from the beginning. So like once you start considering using Docker, if you're making a decision about Kubernetes versus OpenShift, you should also be making a decision about sysdig versus Twistlock versus Aquasec. So those decisions and those implementations you want to start doing as early as possible. And then finally, you don't want to try to do everything at once, right? Like it's good to have a plan. It's good to know where you want to end up, and it's good to know all the different pieces. But if you try to do everything at once with even a sizable team, you're probably going to have a lot of chaos. So the natural follow-up question then would be, okay, well, where do I start if I can't do everything at once? So I first recommend making your application Docker ready if it isn't. So again, we talked about how important that was on the last slide. It's fairly easy to do. It doesn't require you to switch to Docker, which is probably the main thing. So you can make your application Docker ready without having to move it to Docker. You can still keep your same platform, and this is something that can be done by the development team that doesn't disrupt anyone else. The next thing I would say is start experimenting with Kubernetes. So, stand up a cluster. Use EKS if you want, something simple. Get a cluster up and running. Find a hello world image on the internet, build it, deploy it, start adding configuration to it. Just play around, learn the commands. There's a lot of good tutorials out there too. The fundamentals of Kubernetes will help you out immensely. It's probably one of the most complicated tools in the arsenal that we've talked about today. And if you can get the foundations of Kubernetes, even if you do decide to use something like OpenShift, a lot of, again, it's built on Kubernetes, so you're going to have a lot of that information available to reuse. Another good place to start is with your CI pipeline. So if you're using Jenkins, a lot of people are using Jenkins, even if you're using something like Atlassian's Bamboo, their CI server, there's a plugin that allows you to basically execute arbitrary commands in Docker containers. So one thing you can do is start mimicking some of the functionality you have for existing jobs, but use Docker to do it. This allows you, if you've already stood up a cluster and want to find a way to use it, this is a great way to use it. This also gets you writing some of the pipeline code that you're going to need later on. Another good thing to do is build images that you're eventually going to use for your application, right? So if you know you're going to need a JRE image, for instance, for your applications to use, create a Docker file or build your JRE image and start making Jenkins jobs that build that image. So that kills two birds with one stone. You start writing pipeline code that allows you to build Docker images, which you're going to need, and it also creates images that you're going to need to build your application anyway. And then finally, don't be afraid to seek outside help. So I like to tell people, there's tons of training online. There's conferences like this. I mean, I know this is a fairly high-level overview. It's a good place to get started. You can also get more in-depth. You can get more in-depth information at like the tutorials and workshops. There's also the more technical conferences like DockerCon, KubeCon. Those are just a couple. So you can start going to those to get really deep dives into the specifics, although I do recommend some of those for once you're a little bit more advanced. And then finally, if all else fails, you can bring in consultants. So, sales pitch time. I work for a consulting company, Coveros, that does a lot of this stuff and has helped a lot of people do it. So we also offer training. So, one thing you can do is you can bring us in, we give you some Docker Kubernetes training, and then we stick around for a couple days to help you take the lessons learned and apply them to your organization. So that's just one of the things you can do. Okay, sales pitch over. All right, so at Coveros, one of the things we have for blog posts and media is called #Coveros5, which basically says if I were to summarize, a presentation, for example, into 5 points, what would they be? So let's go through them. Number one, moving an application to Docker is more than just putting your binary into a Docker file. We've talked about all the ways that, all the different areas of your pipeline that are affected. We've talked about changes you need to make to your application before you can even begin. So it's a lot more than just writing a Docker file. Number two, you want to pick a container orchestration tool that works best with your needs and preferred cloud provider, right? So if you want to host your own cluster, but you want the support of a big name like, say, Red Hat, then you probably want to go with OpenShift. If you specifically don't want to host your own cluster, but you're dedicated, die-hard Amazon fans, then you probably want to use something like EKS. So keep those things in mind. Number three, manage your deployments effectively with templates. So again, we want to be able to specify stuff that's specific to an environment and combine that with things that are, environment agnostic. Number four, using Docker means new security considerations, which means new security scanning tools. Again, start thinking about that stuff sooner rather than later. And then finally, ephemeral test environments are easier than ever with Docker. Again, we see the humongous benefits we can get by using ephemeral, dynamic, whatever you want to call them, test environments. They can make your organization a lot more robust, give you a lot more testing earlier on. All right, and now time for my favorite part. So I want to hear what you guys think. So for those of you that have started moving to Docker, what do you guys think? What are some major changes you've seen when moving to using containers? I certainly haven't covered everything, and I certainly haven't covered all of the pain points that definitely exist, so I'd love to hear what you guys think. For those of you that haven't, maybe you're just starting to consider it, maybe you've just begun your journey into using containers. What are some reservations that you either had or still have about moving to containers? If we don't finish up here, we're going to get kicked out soon. We can finish this up in the hub. So that's all. If you don't have the hub, you can follow this link here, hub.techwell.com.